Okay, so this is going to be our first foray into electric circuits. And let's change colors here to black. Let me draw an electric circuit for you. So here we're going to have a battery. And we're going to have a resistor here. And we're going to have another resistor here. And we're going to connect that to the battery. And that's not all. We're going to have another resistor here. Okay. And we're going to put some values on this. This is going to be a 12-volt battery, and this is going to be a 3-ohm resistor. This is going to be a 6-ohm resistor, and this is going to be an 8-ohm resistor. Now, I want to stress the fact that I could actually redraw this circuit as such. So I want you to be aware that I could redraw it like this. Some of you actually might find it easier to deal with the circuit on the right as compared to the one on the left, but please understand that they are in fact exactly the same. Okay, so the 6 and the 8 here are in parallel, but the 3 is in series. Now what we're going to try and find is we're going to try and find the current at point A, at point B, and at point C. So we'd like to find IA, IB, and IC. How are we going to do that? Well, first off, if you recognize that this is the positive side of the battery and this is the negative side, and if the current is flowing through this circuit, all of the current that flows in the circuit is going to pass point A. Now that we know that, we can write down here that in fact the total current is in fact going to equal the current that travels through point A. Now that's pretty simple to solve, because what we're going to do is we're going to say, let me switch to black here. We're going to say, all right, well, remember our equation V equals IR from Ohm's law. So we're going to go now, if we rewrite that and we say I therefore is equal to V over R. But in this case, we'll say the total current is going to equal the total voltage divided by the total resistance. Now the total voltage obviously isn't too difficult. That's just 12 volts. There's only one battery. But the total resistance, what is that? Now in order to do this, what we're going to have to do is we're going to have to know how to simplify a circuit. Now if we come over here, I'm going to change colors again. I want you to recognize that this part of the circuit can be replaced by its equivalent resistance. And this is an important concept in making electric circuits more simple, is replacing parts of an electric circuit with an equivalent circuit. And how are we going to do that? Well, let's take a look at it here. If we just, redraw it, it's just basically like this. And that is, in fact, a parallel situation. Now, the equation for parallel resistors is 1 over R total is going to equal 1 over R1 plus 1 over R2. Now, I'm going to put a box around this equation, because that equation is one that you'll have to memorize. And if we solve for it, I'm going to solve for it like this. I'm going to say R total therefore is equal to 1 over 6 plus 1 over 8. And now I'm going to reciprocate this whole thing so that it can just simply be equal to RT. And there you go. I've reciprocated it. And if you want to add 1/6 and 1/8, well, that's pretty easy. Common is 24, so that would be 4 times 6 is 24, so that's 4 over 24 is the same as 1/6, plus 3 times 8 is 24, so 3 over 24 is the same as 1/8. Now if I add those up, I'm going to get 7 over 24, and therefore my answer is 24 over 7. Now I know what RT is. Now that's not the total RT. This RT doesn't refer to this RT. Okay, I should have picked perhaps a different one. This one is referring to this. So now that I know what that is, I know that this red circle here is basically equivalent to, and I can now switch colors here. So that is 24 over 7. So now that I know that this resistor, this thing here, can be replaced by one resistor, that is 24 over 7. Oops. Made a mistake there. That's supposed to be a 4. So this is replaced with 24 over 7. But now that is in series with a 3. And we know that for resistors in series, you simply add them. So all I have to do here for this total resistance of the entire circuit is simply go 24 over 7 plus 3. And that's in ohms. And now I can solve for my total current. And my total current is therefore equal to 1.8667. I can just round it to 1.7 amps. Now, that means I know that at this point, point A, I have 1.87 amps traveling through that point. Now, what's interesting here is that 1.87 amps comes in to this junction here, and part of it splits off and goes to B, and the other part splits off and goes to C. The question is, how does it split? There's a couple of different ways to solve this. Number one way is, I can show you the way to do this using current division. That's probably the easiest way, but I am going to show you another way in a minute. First, let's use current division. The concept of current division is actually pretty cool. Basically, if you just have, and this is current division works for parallel circuits. If you have a total current coming in, and you have R1 and R2, then the current going through 1 and the current going through 2 can be defined by this equation. I1 is equal to R2 all over R1 plus R2 multiplied by the total current. I2 is now equal to R1 divided by the sum of the two, again multiplied by the total current. These equations here are defined as current division. And if we work it out, in our case, we end up getting, for I1, well, now we have to say which one is I1 and which one is I2. Let's say it for the 6. Okay, let's say for the 6. Therefore, the I going through the 6 ohm resistor is going to be 8 divided by 6 plus 8 multiplied by 1.87 amps. Okay, and the I through the 8 ohm resistor is going to be 6, the opposite side, divided by 6 plus 8 times 1.87 amps. Now that is going to be approximately 1.07, and this is going to be approximately 0.8. Now the cool thing about it is, look at what these two currents add up to. You guessed it, that's right. They add up to a total of 1.87, as they should. That's the easy way of doing it. The other way, which is just as valid, but takes a little bit more insight, is the fact that you say, okay, well, look, these two resistors, the 6 and the 8, are actually in parallel. Now, if we knew the voltage between this point and this point, then we could say that the voltage between this point and this point is the same voltage across the 6 and the 8, because voltages across parallel resistors are equal. Question is, what is the voltage from here to here? Well, let's take a look at what's in between here. Well, we've got a 12-volt gain from the battery. Oh, but wait a minute, we've got a loss due to this 3-ohm resistor. So the way we would do that is we would say, okay, well, for this section here, let me just redraw it again. Let's switch colors here. This is a 12-volt, and this is a 3-ohm. So this is a gain of 12, okay, going in this direction. But this is a drop. Now, how much is this drop? Well, using this equation, how much current goes through this 3-ohm? Well, guess what? All of the current goes through the 3-ohm. That's the 1.87 multiplied by the 3 ohms. And in fact, what we're going to get there is 5.6 volts. So this is now a drop of 5.6 volts. Now we know that the voltage between these two endpoints is 12 minus 5.6, which is equal to 6.4 volts. Aha! Now that we know this is 6.4 volts, now when we look at this way up here, we also now know that there's a 6.4 drop across this resistor and a 6.4 drop across that resistor. Let's see if we can now figure out what currents B and C are. That means that if we calculate the current for C, that's going to be VC divided by RC, and that's going to be 6.4 divided by 6 ohms. And there we get 6.4. Let's try this out here. 6.4 enter 6 divided by, bingo, we get 1.07, exactly as we did before. And guess what? If we do it for B, where we go VB, and by the way, that is also, remember what I mentioned before, voltage across parallel resistors is the same, divided by the 8, because of the RB, that's ohms. We get 6.4 enter 8 divided by, and bingo, we get 0.8. So you see, whether you use current division, in which case we got our answers, or whether you simply state, okay, well, these two guys are in parallel, we just need to know the voltage across those two parallel guys to figure out the currents going through them, and take into account that the 12 volt is reduced by the voltage drop across the 3 ohm. Either way, you can get your answer, and it works out beautifully. I hope you enjoyed this solution, showing you how to solve something in more than one way. See you next time.